Hello and welcome everyone. I actually remembered to turn on my sound. Hey Paranor, I see you with the stompy feet. I am back from traveling all over the place. I have so far gone to 7 cities on 4 continents in 7 weeks, and it's been a wild ride, and I greatly appreciate all of you for being so patient with me while I've been off being a delinquent on other continents. So for those of you who haven't been following the adventures on Twitter, last week I was at a meeting called Communicating Astronomy to the Public. It is a very straightforward name for a pretty amazing conference that brought together, brought together people from, we had 53 different nations represented, and all of us are working to communicate astronomy all around the world. Hello, Keeper of Maps. Hello, Cosmic Lettuce. It must be so much warmer in southeastern Arizona than it is here. We had snow yesterday here in Illinois. So, yes, astronomy does rule. So while I was in Japan with people from 53 different nations, we had everything going on, from people talking about all the different ways that we can communicate out astronomy, through how press releases are put together, to how we do podcasts. Aviva Yamani and I did workshops on podcasting, to better use of social media through storytelling. All sorts of different things were going on. I was originally planning to do some Twitch streaming from there, but I found out that our good friend Skylius was on the front page of Twitch last week, and she was getting something like 15,000 viewers at a time. And I know my place, and my place is to sit back and watch when something like that is going on. So I joined her one day on her Twitch channel, but other than that, I kept off of Twitch and let her have her amazing week. And we just need to celebrate that. Yeah, Paranor's pointing out quite correctly, the largest it got was 16K at one point, that there was a stadium-sized viewership watching one woman stream science. And that is truly amazing. I did get up extraordinarily early one morning to join Skylius. Yes, I was up at 5 a.m. to do it. But you know, these are the things we do when we know there's an audience out there waiting to watch, waiting to get involved and do more and learn more. So I had with me my camera, I had with me my microphone, and I used them to teach other people how to podcast. And I now have a very well-traveled set of equipment. And next week, I'm going to be flying out to San Francisco to go to the headquarters of the of the Astronomical Society of the Pacific, which is the organization that I work for. And I will probably be streaming from out in California next week. Not on Tuesday, I leave Wednesday, but later next week. This time, I did not have problems with my audio recorder, Keeper of Maps. It turns out that when you have a Japanese-made audio recorder with you and you fly to Japan, you're actually okay. I will say that I have never met anything as efficient as the entire country of Japan. It is an amazingly clean, well-organized, futuristic. I felt like I had stepped into Tomorrowland at Disneyland, but like for realsies. There in Tokyo, is a monorail system that is used for everyday transportation. It's a truly beautiful place that people are cordial to one another, benevolent towards insane, crazy people who don't speak their language, like me. Yes, there is a station called the Tokyo Transporter that is just a subway station. And I did take the Tokyo Transporter. And getting on the subway there took me into that part of Tokyo that you see in all the movies with the giant screens and everyone crossing in crazy directions. It was absolutely wild. I will be sharing out in blog posts everything that happened, both on my personal channel and on the CosmoQuest stuff. It did seem exactly like SimCity. It was actually kind of surreal. As Aviva and I were walking around, Aviva is the project director for our 365 Days of Astronomy podcast. As we were walking around, Aviva and I kept pointing out buildings that looked just like different styles of architecture that you hit while playing SimCity Build It. And it was like Kyoto had some of the buildings, Tokyo had the Tokyo buildings. Yeah, and we did even find Godzilla, in this case, a statue built out of toys that was deeply troubling when looked at with a zoom lens. But I really can't recommend going to Tokyo enough. And while lodging was quite expensive, food and everything else was completely reasonable. Thank you, Paranor, for that compliment. I am utterly, totally, and completely jet lagged. I am faking it really well right now. Let me see if I can pull up that picture of Godzilla that was found. Hold on a second. This is going to require me looking around on my hard drive for a moment. So as part of the trip, we sat and started talking about how in the future we're going to continue all of the efforts that we started there. And one of the big things that came up is next year is a bunch of really important anniversaries in astronomy. First of all, it's the 100th anniversary of the formation of the International Astronomical Union. And Cosmic Lettuce, Tokyo actually wasn't nearly as crowded as I expected, but I was there on a weekend. So anyways, I was saying next year is the 100th anniversary of a variety of different things in astronomy. The International Astronomical Union's formation. It's also the 100th anniversary of the 1919 eclipse, which was used to prove that... Thank you for the follow, T-Color. I didn't know my computer was so loud. That is awesome. And you startled me much more awake. Both are very useful. Thank you for the follow. So in 1919, there were observations made of a solar eclipse. And the observations weren't just of the eclipse itself. They were also of these stars that became visible while the sun was eclipsed. And by precisely measuring the locations of those stars, it was possible to determine how that light was bent by the sun's gravity and to prove that relativity was completely real. Hey, Uncle Bill, you came and you have all the emojis tonight. I did not know that so 2018 Keeper of Maps is the 150th of the Royal Astronomical Society of Canada. The skies in Japan are not dark cosmic lettuce. No, they are very bright skies. They weren't as bright as I anticipated, however. So there's that. Yeah, the skies there are quite light polluted, unfortunately. but such is as it is. So let me share with you the Godzilla that we found. Let me switch views. So this monster here is a rather terrifying Godzilla. Let me zoom in on his face. He's made out of toys, and the longer we looked at him, the more strange and troubling toys we found. Now, when I zoom out, it's just a brightly colored dinosaur that was hanging out in somebody's front yard. Cool, no big deal. But yeah, he was made of toys. He was horribly disturbing. So hey Brozil5, thank you for the follow. So it shows you that interesting and creative things can be done in many different, sometimes terrifying ways. Now, in addition to finding Godzilla, as I keep trying to finish, I'm going to finish this thought. No matter how jet lagged I am, I'm going to finish this thought. In 2019, we're going to be celebrating that 100th anniversary of demonstrating that relativity is real. You may not like it, you may want to prove it's false, but it was real. It was a thing that we could see in 1919, and now we use every single day with our GPS detectors. So we're going to celebrate that. And then it's also the 50th anniversary of going to the moon. So there's a whole lot of important anniversaries happening next year. And we're going to make a global celebration of astronomy out of this. We're in the early planning stages. I'm still trying to figure out exactly what all we can do with CosmoQuest. One thing I know we're going to do is we're going to be working to refocus our 365 Days of Astronomy podcast to celebrate a lot of the different things that are going on, to highlight them, and we're going to be launching some new podcasts as well, including right here on Twitch. At the end of this month, possibly not next week, but the week after, we're going to start a new version of an old series. So to answer the question about how big Godzilla was, he looked to be about 4 foot tall. He was up on a hill that we couldn't quite get to him. But yeah, he was a very disturbing Godzilla. So here on Twitch, we're going to be starting a new version of our old Learning Space podcast. I'm going to be bringing it back. I'm going to be hosting it here on Twitch as part of the CosmoQuest X channel. And every Thursday, and we're still working to set out the times, I think I'm going to alternate between doing it early in the day and late in the day to hit different parts of the world. It's going to include 3 basic segments. The first segment is going to be a news roundup, sort of like what the late night people do, talking about regular news. We're going to do it focused strictly on astronomy news. Then we're going to have a special guest. I'm definitely going to invite Skylace on. You're going to see some of your old friends from the Weekly Space Hangout, but also a bunch of new faces where we're going to invite people from all over the world who are doing amazing projects to come on and talk to you about the things that they're doing. The final segment is going to be some sort of a product review. Isn't quite the right word, but we're going to introduce you to different things that are available to help you learn and do astronomy, whether you're going outside and looking up or going online and looking for things to do, or even just trying to find a good book to curl up in a chair with. So that's going to be our new Thursday spotlight. Now, we are also working to expand things into other languages, because it isn't only English that this planet speaks. We're working to find new people to collaborate with, and I think the first language we're going to break out into is going to be Spanish. We are going to do that on a separate channel that we will be promoting here, But we're not going to confuse you by having multiple languages on one Twitch channel. So stay tuned. At this point, we don't have any French speakers, Keeper of Maps. And it turns out that Spanish is actually one of the more spoken languages on the planet. So we're going to start there because, hey, thanks a lot, Kalos Fury. You also have a cool username. Also a bit scary of a username. Thanks for the follow. So yeah, I know we're not going to do French, not initially at least. So we found a bunch of Spanish speakers who we're going to partner with. So there are lots of exciting things to come. And if you have any ideas for things that we should do for the International Astronomical Society's 50th or 100th anniversary, for the Apollo 50th anniversary, for the Relativity 100th anniversary, let us know what you'd like to see. And we do need a French partner from Myanmar. I am not the one to try and speak French to them. I think I have demonstrated that many times. Thank you for the subscription, Keeper of Maps. That's kind of awesome. I now feel the need to try and learn how to say something in French other than I learned the sentence "Como t'appelles-tu?" And I don't even remember what it means. It's just something I learned in French. And yeah, no, I can't speak French. Ja говорю по-русски. Я не знаю французский язык. I do adore poutine. Poutine is not French. Poutine is Quebecois. For those of you who don't know what poutine is, it is this amazing dish. It originally came out of Montreal, where you take French fries, otherwise known as chips, to those of you who are in the UK, and you slather them with cheese curds and gravy, and they're simply awesome. And I don't speak that language, Keeper of Maps. Savez-vous plus? I don't know. And no, Quebecois is not French. Anyways, okay. So those are highlights of the meeting I was at last week in Japan. If you have the chance to go to Japan, I really can't recommend it enough. It's utterly safe. I've traveled all over the world, all over the United States. I've never felt as safe as I felt in Japan anywhere else. You see people in bookstores pile their stuff at a table, take their wallet, go up to get coffee, and just leave their stuff, computer included, and it's safe. Welcome, Drop Bear. I really hope you're a Southern Hemisphere drop bear, because some Southern Hemisphere drop bears are truly the best drop bears. Okay, so one of the things that we do around CosmoQuest when we're not producing a ton of new media is we do citizen science. And one of the things I haven't had a chance to talk to you guys about is we recently updated all of our Mappers Problems projects. Hey, Miklos, welcome. I'm glad that you were able to catch me here. I'm going to go ahead and switch which screen I have up. Yes, that worked. I can be restrained, but I'd prefer that no one tried. Antipodian drop bear. I approve of antipodian drop bears. Anyways, so one of the things that we did recently is we updated all of our Mappers projects over on CosmoQuest. So if I go in to map the moon, it doesn't look spectacularly different, but oh, come on, behave, website. I hate it when I'm streaming and streaming causes it to be sad. So the big thing that we updated, and I am stupidly proud of this, is we updated all of our icons, and they're now my artwork. And so these are little things that makes me happy. And we updated the whole tutorial where it steps through and it makes sure that you fully understand all the different tool sets that we have. So it goes through and it shows you how to erase your mistakes, for instance. It talks about, hey, let me show you how to mark these, because we've had some people that are marking the shadows instead of the edges of the crater, and we just want to make sure you fully understand everything you can do to help us map everything out. And yeah, sometimes the spit and polish is the fun stuff. And we went through, we added a bunch of new examples. We're making sure that folks know, hey, thank you for the 10 bits, Miklos. It's still Shamrocks. That's awesome. Thank you. I kind of didn't know you could get bits by watching ads. We're all going to be a bit perplexed and hope that you please explain that, Miklos. Miklos is, if you're the person I think you are, is a good soul from Texas that I met many, many moons ago and have kept up with since then. Okay, so going through the tutorial, it walks you through all the different steps that you can do, teaches you all the different things, and then it sets you loose on some much more difficult images, helping people realize, yes, sometimes the moon is a busy place, and that's good to know, Miklos. I'm glad I'm the person. Wow, I'm jet lagged. Yes, I'm glad I'm the person I think I am, but I'm also more glad that you are the person I think you are. Sorry for the jet lag causing weird language bits. Okay, so here it's going to actually yell at me if I do something really wrong, but it yells at you in a very polite kind of way. So let me go ahead and delete the lousy mark that I made. And it's going to encourage me. Hey, thanks for the follow, person with an extraordinarily depressing username that is unfortunately quite true. That did happen at YouTube today. So here I am marking a busier part of the moon's surface. I'm not going to try and figure that out. I'm just a scientist marking craters on the moon because the universe likes to throw rocks at the moon. And this means we can do science with rocks that have hit the moon. Now, the area that we're looking at, what's interesting is you can see there's a bunch of these really crisp-edged little tiny craters all over the place. Turns out that the debris in the solar system, there's a lot more tiny stuff waiting to hit the moon, the earth, and everything else than there is big stuff, which we're grateful for, because tiny stuff, our atmosphere will burn up. Big stuff gets through and kills dinosaurs. When I look at this image, I can see, let me hide what I've done. There's some super, hey Skycake, thanks for the follow. I can see that there's some really rounded edges, really worn down edges on some of these things. And that's because every time the moon gets hit by a space rock, it shakes a little, and that vibrates down the edges of the crater. The moon is constantly getting blasted with micrometeorites, and those are wearing down the edges of the craters. There's lots of little things happening that over time wear down the edges of the craters. And looking at this, I can see some of the really worn craters. Okay, that one it didn't agree with me on. And I'm just going to go ahead and mark things until it says I'm done. Hey, art is passion. That's how you parse that. You have a cool username, and I am like honest to God dyslexic. And I started to read that as anti, and then it wasn't pasta, the next word. And then I realized that wasn't anti, and it's a cool name once you grok it. So welcome, new person. So I just marked a bunch of craters on that part of the moon. That was the bright part of the moon. So when you look at the moon, you see the old man in the moon, which is made out of mare, which is dark lava-y stuff that oozed out on the moon during a period called the Great Heavy Bombardment. This was when the moon was just getting inundated with asteroid after asteroid after asteroid. And yes, I love the word grok drop bear. So for those of you who don't know that word, it's from a Robert Heinlein novel, Stranger in a Strange Land. And it refers to that ability to understand something on a truly deep level. And it's just, it's something more than understanding. It's just a useful word to have. Anyways, so back in the day, about 3.8 billion years ago, the moon was just getting bombarded with asteroids, and it still had a fairly warm core at that point. And some of these asteroids that formed these great big basins actually cracked in, and it oozed out lava. So if you'd been like a bacterium 3.6 billion years ago on the Earth and had eyeballs, which you wouldn't have had 3.6 billion years ago on the planet Earth, you would have been able to look up and actually see lava flowing on the surface of the moon, where we now see that dark old man in the moon. I like the way you put that, keeper of maps. And thank you, Uncle Bill. That's sweet. Yeah, so I love Heinlein. Well, I love some of Heinlein. Some of Heinlein's stuff is just kind of, no. It depended on where in his career he was writing. Anyways, moon, the dark stuff. This is called mare. The part that I just did is the light stuff. It's called regolith. It's just slightly different compositions of moon rock. And it's spelled like Maria, the dark stuff. It's pronounced mare. It's spelled like Maria. And the evil part of me always thought, if I have a daughter, which luckily I've never had, I should name her Maria, but pronounce it mare because of the moon. I would have been evil. Luckily, I have no children, so no child suffered me having to name them. So anyways, now I'm going through and marking craters here. Now, when you look at this crater, let me hide what I just drew. You can see there's the edges of a crater right here, and then it's splattered all around with this bright stuff. This is because when the moon gets clobbered with space rocks, it sometimes reveals that the material underneath what's on the surface is a different color, and then just splatters that all over the place. So through cratering, we're essentially able to dig into the surface of the moon. Not us, we just wait for the universe to dig in. Yeah. Oh, I'm trying to follow the conversation. I'm not sure what I'd be dealing with for life, Miklos. I missed something somewhere. Okay. Anyways, going back to marking craters while being very jet lagged because I was in Japan on Sunday. So craters allow us to see down into under the surface of the moon. And there. And in some places, we actually get neat what are called terraced craters. These are craters where different levels of the surface of the moon have different densities. So as the asteroid passes through, it will blast out a lighter layer on the top, chisel down into the bedrock underneath, and we can see those different layers in the crater walls. All sorts of really cool stuff gets literally revealed with asteroid impacts. And we're trying to study all of this with moon mappers. And our hope is that by getting enough people to help us mark enough images, we'll actually be able to train machines to go through and map the moon out in detail for us. But we can't get there by ourselves. Yes, Miklos. Oh, now I follow. Yes. This is why it's good that I'm not allowed to name children, because I would give them names that would cause them to be miserable. Yeah, it's one of those things. I like the problem of naming a dog Enceladus versus enchilada. Those are two similar words that are very different. Oh, Paranor, I will see you later. I have been getting lots and lots of dog slobbers. It's true. I actually took my dog to the groomers today because I also got wet dog slobbers at one point. So I will catch up more with you later, Paranor. Okay, I'm going to click image done on this and move on to the next. So I have finished the tutorial. I'm going to go ahead and log in. Let me log in with Twitch. Okay, apparently our Twitch login is currently throwing errors. That makes me sad. I'm going to have to talk to my programmers. That was sad and frustrating. Oh, I know what happened. I logged in with WordPress earlier because I'm an admin, and it turns out that when us admins log in with WordPress, it just breaks the entire system. So let me log out and try logging back in from the front without being logged in. Yeah, that worked. Okay, so the moral of the story is when you're an admin, you sometimes can break your own software just by being an admin. Eddie's the one for the slobbers. Eddie is my dog, for those of you who don't know. I'm glad to be back, everyone. Okay, so that was the moon. We have all these different worlds. We need your help with all of them. And what's interesting is each of these worlds, they're all rocky worlds, and they all look radically different. So here's Mercury. And one of the reasons it looks so radically different is, first of all, the sun pretty much blasted away anything on the surface of it that might be considered loose or dusty. It is baked completely dry. It's tiny and dense and hard, and when things hit it, they usually have a pretty high velocity because they are getting pulled in by the sun. So poor Mercury has just been creamed by asteroid after asteroid after asteroid. And so you have this horrible surface that has been mangled. Drop Bear, you knew someone who had dogs that were Zubinel Ganubi and Zubinel Shamali? That would be hard. I know that both those stars were used as server names at Oxford University at one point, and all of the grad students hated having to SSH into those servers. Yeah, that's... I know what the don't run with servers access refers to, and that is awesome. Yes. Yeah, Zubinel Ganubi is just one of those "are you a true astronomer" kind of names. That would be mean to do to your poor dogs. Okay, anyways, marking the surface of Mercury. Now here, our images aren't quite as high a resolution, so everything looks a little bit less sharp. These are images from the Messenger spacecraft. And what we're trying to figure out here is just what is the history of this poor, beaten, battered, broken surface. And one of the things that makes it really difficult is some of these craters are formed by primary asteroids, not primary asteroids, primary impacts. Let me get a picture of Mercury. And some of them are formed by secondary impacts, and those are some confusing words. Let me get a good picture up, and then I'll work on explaining this. Let me get a good big picture up. Sorry, I should have thought to do this ahead of time. You are a good image. I shall view you. Just a second, and I'll have it brought up on my screen. Come on. Maybe I'll have it brought up on my screen. I went to a website that doesn't want to embiggen. Okay, there we go. So this is a NASA image that I just pulled up over on space.com. And if you look at this, you can see there's a crater impact up at the top, and then there's all of these lines radiating away from that. Well, these lines radiating away, those are the secondary impacts. So some space rock, asteroid, comet, whatever, came in, impacted Mercury, and when it dug into the surface, it dug up boulders and then flung those out, and those boulders flew out and ended up forming all of these lines across the surface. You can see something similar happened. Sorry. You can see that something similar happened over here. Keeper of maps. If you hide your marks, can you draw more marks and keep both sets? I don't actually know if we allow you to keep drawing marks after you hide your marks. Let's find out. I'm going to draw a mark. I'm going to try and draw a mark. I have completely confused my computer. There we go. I'm going to hide a mark. I'm going to try and draw a mark. Yeah, so you can't draw while your marks are hidden. You can only draw while your marks are shown. So that's just to allow you to see what's underneath. So I can look to see, is there anything I forgot to do? Do I need to move this? Whoops, that wasn't a move. That was a delete. Or, sorry, that was a mark. So, hiding marks is useful for things like, let's say I mark this crater, I mark this crater, and I'm trying to figure out if this thing in the middle is a crater or not. I just hide. Oh yeah, that's a crater. And then I can draw in the missing crater. It's also useful when I'm doing explaining like I'm doing now. Now this crater I just drew, this is actually a pretty cool one because you can see it has a completely flat bottom but has this really steep side over here that is illuminated by the sun. So craters come in a whole variety of different forms, and each of these different forms tells us something new about the surface. And it's only from studying all of them that we're able to get a complete understanding eventually. Now, Mercury has just been clobbered over and over and over again, and that was not what I meant to do. Let's drag you over here and change what size you are. Whoops. There. And then I keep drawing new ones instead of dragging. I'm not very good at dragging. Okay, let's try this again. There we go. So you can see just how complicated these get very quickly. So we're not currently planning to use it to make more accurate 3D models. What we're actually using it for is to mark out hazard paths for various spacecraft to answer a variety of different science questions, like when was the last time there was volcanism on Mars, and where are the youngest surfaces on Mars. All of these different science questions right now don't require us to have better 3D models. It turns out that the craters, we could do a lot of interpolation. See you later, cosmic lettuce. Cheers, cheers, peace, peace. That's a fabulous exit saying. Awesome. Have a wonderful evening. So it turns out that while you can get some information from crater shadows as to the depth of the craters, sometimes it's just enough to know the craters are there. Counting the craters and measuring the proportion of the craters that are different sizes, it's called the crater size frequency distribution. By measuring that, we can figure out how old different surfaces are. If you look at a region of any of these different worlds and you see that it has so many craters on the surface that any new crater has to demolish some old crater, that region of the moon is really old. If you see an area of the moon that is mostly smooth and boring looking, that's a very young area. And so sometimes just counting craters helps us get at the age of a region. And with the moon, at least, we've gone and we've picked up rocks, we've brought them back. We can do isotopic measurements to see what is the ratio of this radioactive atom to this non-radioactive atom. And that will allow us to say, if you look at the moon and you see this distribution of craters of this different type of sizes, then we know from the rock that we brought back from the moon that this area is this exact age, and then we can extrapolate to say that everywhere else on the moon that has that same size frequency distribution should be roughly the same age. So this is how we get at the ages of things. Now, unfortunately, with Mars, we haven't been able to bring back any rocks yet. We want to, we hope to. This is hopefully going to happen in the next few decades. But until then, counting craters gives us the relative ages. And we have models that give us hints of, well, if this is the cratering history of the moon, and we see this on Mars, these regions are probably with error within these regions in the past. So we try and interpolate to use what we see on the moon, what we've learned from moon rocks, to constrain what we see on other worlds. And with all these little rovers we're sending out, it's always good to know exactly where it's not safe to put a rover. So we're doing detailed maps so that we can figure out what's scientifically interesting and where is it safe to send a robot to travel. We're going to later on be working, if all goes well, with the OSIRIS-REx mission, and we're going to be helping them figure out where's the rock they're going to pick up and bring back to Earth. So these are the things that we're doing, and our goal is to only ask you to do things that scientists can't do without your help. And it turns out, as of today, we can't yet train a computer to mark all of these craters for us. But the hope is that using your data in the not too many tomorrows, we'll be able to train a computer and then ask you to help us move on to other projects, move on to doing more interesting things. So let's work on this and hopefully slowly conquer the backlog of different science that needs to be accomplished. So Keeper of Maps is asking, won't places that were recently hit, which are probably more hazardous, also more likely be interesting? We don't know. So there's a few places on Mars that have what appear to be very young craters, and at least one crater that we've identified has formed since we started watching Mars with the Mars Reconnaissance Orbiter. Now, that particular section of Mars just happens to be a random place on Mars that was hit by an asteroid. And it's no more or less interesting than any other by and large, other than there's recently revealed surface material so we can better see what organics might be revealed or something. We don't have a rover anywhere near it, so we can't actually go do that. But it's certainly not a more hazardous area. Now, that's not to say that if something big hit and made a big crater and strewn boulders in all directions that it would be difficult. It all depends on what it is. Now, the subsurface strata, it actually turns out that because there's not a lot of weathering on these worlds, that once something's revealed, it stays revealed. What changes over time is organics get broken down in the ultraviolet light from the sun. Here it turns out we actually want to go to the sand dunes, where the sand dunes are constantly revealing new surface. Those are the places that are going to have the newest materials. I don't think it's more likely that some place that had a fresh impact is going to have more obstacles. There's plenty of other hazards, from canyons to volcanic fields to boulder fields from secondary craters. It's a whole variety. Let me find a picture of this new crater so that you can see what I mean. They often stretch its colors to make it look blue. It's not actually blue. And I apparently need to replace parts of my keyboard because not all my keys wanted to type when I did that. Okay, so it turns out there's a couple of different brand new ones. So let me get both of these. Visit. So this is from Fraser Cain's website, Universe Today. So here is a picture of a nice, fresh crater field. This was spotted in December of 2015. Now, it's not the only one like this. The much more often shown one, I'm going to pull up in just a second. I don't know if it's even going to be able to fit all on the screen at once. So this is the one that's more often shown. And this debris that you're seeing, that's just soil of a different color that's been flung in all directions. You can see in the details that these are sand dunes in all directions. This is just sand. And the material on top, it's just a dusting of basically a different color of dirt. So this isn't more or less hazardous. I think the biggest issue is that it's sand and things get stuck in sand. And it's not that it came straight in, it's that it wasn't at a hugely oblique angle. So this one appears to have been at either a hugely oblique angle or, no, I don't want to subscribe right now. And I'm looking to see if it says either that or sand got it. So here you see the two different images, one no crater, one with crater. And it's not saying what the incident angle was. Okay, I'll have to come back and read this later. It turns out that pretty much the only way you can get one of these impacts that isn't spherical, that isn't round in how it looks on the surface and ends up asymmetrical like this, is if you're coming in at less than 5 degrees. So that means if here's your surface, you have your impactor coming in at this kind of an angle. So a very low angle. Anything higher than that, all of the kinetic energy of the asteroid that's coming in to do that impact is just going to get released into a spherical shock wave. And the spherical shock wave makes a circular crater on your surface. It's almost all craters are round with a fairly symmetric debris field just like this one because of that transformation of all of the kinetic energy into a spherical shock wave. The fact that this one is so asymmetrical makes me wonder if it was the wind blowing in part because, well, Mars has wind. I need to look up more about that particular one. Barringer crater is completely round. In fact, most of the craters on Earth are some version of round. Let me see if I can pull up a montage of the craters on Earth. There's actually some pretty amazing craters up in Canada. Here we go. 10 biggest impact craters on the planet Earth. These are exciting things. This is live science. This means the site is likely going to have advertisements, but my ad blocker is so far keeping us safe. So here we have a crater with absolutely no information about it. So I'm going to click through these. Okay, here we go. Vedford crater is the oldest impact crater on Earth. I just want to know where it is. South Africa. So this is, it was an asteroid bigger than a mountain that formed this. So you can just make out the crater edges here and over here. Then Sudbury, this is up in Canada. I believe it's up here. Ontario, Canada. So I don't know if this is too near you, Keeper of Max. Yes, Manakonkan is one of the great Canadian craters. It's a ring-shaped lake or reservoir now. Oh, sorry. I didn't realize I needed to scroll. Okay, so here's Sudbury crater up here. Thank you, Fenmil. I'm so sorry that you suffered from 50 minutes of network issues. That's horrible, but thank you for the subscription and welcome back. Yes, Sudbury is a nickel meteor. Then here's Chicxulub. This is actually a gravity map to make this. This is the crater that's partially in the Yucatan Peninsula. Oh, it was the green oblong structure? Okay, I'm just going to be confused about this one. I thought it was the lake. But I leave room to be completely wrong. Then here is another crater here. This is in Russia. It's 62 miles wide. And I love this. It contains diamond reserves. That's just amazing to think about. This is the Manakonkan crater. I just love, this is my favorite of the Earth craters. It's also now a water reservoir. So the fact that people are drinking meteorite water just pleases me to no end. So this is up in Quebec. I didn't know it was one of the best preserved. There's something ironic about a crater that's filled with water being one of the best preserved. This is one that I would never have been able to identify had they not drawn lines. Archiman crater. It's a round impact crater. Where are you? Southern Australia. Australia is another place that has several of these. Oh, I did not know Chesapeake Bay had a crater in it. So I'm learning things along with you guys. Manakagan? I would not. Okay, it's not a Native American? Okay, at some point, Keeper of Maps, when we are on Zoom, you're going to have to explain that pronunciation to me. Because I read it as though it were like from one of the Native American tribes. So I had no idea that Chesapeake Bay had a crater. I think Live Science is just introducing us to things that I can't pronounce now. So here's more from South Africa. Here's Kara Crater, which is another one I wouldn't have been able to find. This is again in Russia. Here's another one I didn't know about, and I can't see it in this picture. So Live Science, you're being useless. Anyways, our planet Earth is completely covered in craters. That slideshow didn't even show all the ones that we've used in various other things with CosmoQuest. So I'll have to put together a compendium of all the different craters. Oh, I'm sorry. I'm renaming them, Kyle. Thank you. I grew up in Massachusetts where we had all sorts of different Native American names all over the place. And so you sort of learn how to pronounce a lot of different things, and you get used to calling them Native Americans, or, because of my age, Indians, because we are horrible human beings. And that was what I was taught as a small child. But you're right. Canada does a great job of saying these are the First Nations people, and that is the correct way to call them. I wish the United States had adopted a similar nomenclature to calling them First Nations. My elementary school was called Namnasset after the local Native American tribe where I was growing up. Okay, so I've now been babbling. Go map things. We need help mapping things so that we can train software to take over the mapping, and then we can go do better and other and different science. The more you map, the faster we'll be able to train software to take over. And then once we publish that science, we'll go forward and do more science. Yeah, okay, that's a fair assessment, Keeper of Maps. You do a better job than we do. Let's go with that. You do a better job. So that's really all I had planned for tonight. I'm sorry, Bill. Oh no, Bill, I'm so sorry. Yeah, I was just going over the differences in surfaces. I'm sorry. So do you guys have any last minute questions? Otherwise, I'm going to go wander off and work on some things. I will probably be off and on this week from my office, working on trying to set up better setups for OBS. That was a stupid sentence. I'm trying to figure out how to do better lead-ins. I'm trying to figure out how to do better switches between scenes. Basically, I'm going to be playing with graphics in OBS, and you may occasionally see me popping in to test things out and seeing what people like and don't like. Yes, you missed a creepy Godzilla. I'm sorry that you need to find an outlet, Keeper of Maps. Electricity is not yet something freely available out of the air. So stay tuned. Matt, as always, will be doing his office hours on Wednesday and Friday. And let me open up the weather. I mean, ideally, if the weather isn't a hateful thing, I'm going to be working with Big Joe on Sunday to do some telescope stuff, but because we got a telescope, we broke the weather. It has essentially been raining for several weeks now. That was not what I meant to do. I meant to do that up here. Edwardsville, Illinois. 10-day forecast. So if the weather is at all clear on Sunday, we will play with telescopes. Oh, it's supposed to snow on Sunday. Wow, we broke the weather. This is what happens when you get a new telescope. You break the weather. Okay, then. Yeah, go ahead, Bill. Ask a quick question. Or a slow question. You can do that too. Yeah, I saw about that tornado in China. That was horrible. They don't have sirens and things like that to tell people to seek cover because tornadoes aren't normal there. So for those who don't know, there was, I think it was an F5 tornado, which is as powerful as they get. That's like what destroyed the city of Joplin a few years ago. There's a F5 tornado in China, and it basically destroyed everything it touched. Come on, Bill, what's your question? You found a covert plug? Okay. Keep your plug to yourself. Yeah, it was, the news reports were pretty awful. Oh, so I had a planetary scientist comment on the weather we're having right now to me, and they were saying that what we're experiencing is there's a convective cell that built up that is taking warm air and dumping it on the Arctic and pushing the cold air from the Arctic down onto, well, Jackson, Wyoming, and now southern Illinois. And we are now dealing with misplaced cold air, bringing us winter number 2. So Bill is saying that he knows that on Mars the images are 450 by 450. I don't know off the top of my head, Bill. Drop me an email because I currently have absolutely no memory due to jet lag. It turns out that jet lag actually destroys your short-term memory for a little while. Drop me an email, Bill, and I'll look that up. I just don't remember. The 450 by 450, yes, that part is true. I don't remember the resolution of the images. Yeah, Ontario is also getting blasted right now. It's just a really weird year. All of our daffodils are in bloom, and the tulips were getting ready to do something, and now they're just flat because they got snowed on and they didn't appreciate it. And luckily, none of our fruit trees had bloomed yet. So, yeah, let's talk about happier things like hitting rocky worlds with space rocks and forming craters that then we can mark and map. So go mark craters on Mercury or Moon or anything else, and help us get to the point that we can train our algorithms to take over the work, and then we'll move on to doing new, different science with CosmoQuest. That's all I've got. And Bill, please send me your calculations, and I'll work through those and see what I can figure out. And for the rest of you, stay tuned this week. I'll be popping in off and on. I will figure out something to do Sunday while our telescope is waiting for the snow to go away. And yeah. Life is as it is. If you're an observer, when you buy a telescope, the weather goes to pot. Yeah, I'm going to go seek coffee. Jet lag is getting me. So wherever you are in the world, have a wonderful morning, evening, afternoon. Go do some science. Go to CosmoQuest.org, and together we can explore this universe. So thank you, and be awesome. I'll talk to you all later. Bye-bye.